There's a few ways to write the net change theorem. I'm going to write it the way that I think we can understand it the best. And I think the best way to talk about it is the example we first started in class, which is this. If you want to be able to find total distance traveled, or I'm sorry, displacement of an object, displacement of an object is very easy to find. And you might wonder, well, why am I talking about displacement? There I was just talking about the total accumulation of oil. It's the same thing. Whether you're talking about gallons or whether you're talking about miles, it's the accumulation of everything. So total displacement of an object is the integral from the start to the end of the velocity function. So to be clear that we understand what that looks like, if I start here and it's 20 feet to get to the door, if I walk to the door and that's 20 feet and I walk back, what's my total distance? 40. What's my total displacement? 0. Get that? So this would produce 0 in that situation. It would show as displaced 0. If you want the total distance, you have to count what we call positive movement and negative movement. So that would be the absolute value. So distance traveled is equal to the integral from the start to the end of the absolute value of v of t dt. We got like 3 days on this, folks. This is a big idea. And it is one of the most essential pieces to you doing well in the AP exam and on this next test. If you don't learn how to do this for the next test, we are in trouble. Okay? And it's definitely something we take time on, and we go over and over again. You do a checkpoint on it, be on your study guide, everything. You're going to try some with a calculator. You're going to try some without a calculator. Let's try without the calculator first. It says a particle moves at a velocity modeled by this function. So I'm not given the position function, I'm given the velocity function. Modeled by t squared minus t minus 6. T is measured in seconds, v is measured in meters per second. Find the net change or the displacement of the particle over the time 1 to 4. And then find the total distance traveled. So what we want to do is we want to give you a visual to understand what's going on as well. And so I'm going to draw a little graph here. Sorry, my mask is falling apart. Hate that. So I've got this guy. What shape does it make? Parabola. If I factor, I get t minus 3 times t plus 2. So that means it crosses the x-axis at both -2 and +3. Agreed? So I'm going to mark off +3. I'm going to mark off -2. So we'll see if you guys can understand a little bit of what we just drew. Because it's been a while, but we have talked about this before. So hopefully you'll see how I've tried to set us up for these moments so it's not as confusing. Right here, am I traveling to the right or am I traveling to the left? Am I traveling to the right or am I traveling to the left? Okay, let me make this statement, and you can think about it once more. I'm traveling to the left when velocity is negative. I'm traveling to the right when velocity is positive. Am I traveling to the right or left? Is this the velocity function? Is the velocity function positive or negative? It's negative. It's below the x-axis. Let's get to Morgan's point. Morgan, you said positive, right? Why? Because you're sloping up, right? That means the acceleration is positive. You're speaking of the derivative at that point. Get my point? The velocity function is negative. I'm traveling to the left. How about here? Traveling to the right. Everybody got that? So see how I was modeling in class, walking to the right and walking to the left? We have the same thing happening. So what we would like to calculate are really these two pieces. We're going from 1 to 4. So that means I'm going to start at 1, and I'm going to accumulate distance to the left. And then I'm going to accumulate distance to the right. By looking at the graph and just my rough sketch, do you think I move further to the left, or do you think I move further to the right? Looks like to the left, because that looks like where I've accumulated more area, right? That's what it would seem. How do we figure out the total displacement? Very easy. The displacement of an object, and you'll see this, this will be for the rest of our math time here. We'll come back to this all the time. Displacement of an object is very simple. It is the integral of the start time. What's the start time? It's 1. The end time is 4. And what do we integrate? We integrate the rate function. Our rate is given to us in form of velocity. So we just do t squared minus t minus 6 dt. Do you already know how to do that? Yeah, that's easy, right? So the big idea today is that you understand that if you integrate velocity, you come up with distance. Let's now go about our business. What's the antiderivative t squared minus t minus 6? Good. We're going to evaluate that at 4 and at 1. I'm going to do this one without a calculator. There are times on the AP exam you are required to not use the calculator. So we'll see how this works. We cube 4 and we get 64 over 3 minus 4 squared is over 2 minus 6 times 4 is 24. So that's how I set up my first part. And it seems like about every other year I make a mistake on this problem, so please check my arithmetic. Now what do? Plug in 1 and we get 1/3 minus a half minus 6. So sometimes to help me in my work, and you guys started to figure this out as you were working through the fundamental theorem calculus part 2 on the last unit, is sometimes you can do things like this. 64 over 3 minus 1 over 3 is 63 over 3. What's 63 over 3? Very good, 21. And then it looks like I have a minus 8. I have a minus 24. I have a plus 6. And I have plus a half. So I'm able to calculate this pretty straightforward without using a calculator. What's 21 minus 8? 13. What's 13 minus 24? Negative 11. Negative 11 plus 6. Negative 5. And negative 5 plus 1/2. Negative 4.5. I'll write as negative 9 over 2. We have a label. It says it measured in seconds, measured in meters. So negative 4.5 meters. So that means that this object is 4.5 meters further to the left than when it started. So if I started here, I walked to the left, and then I slowly walked back forward. I did not reach my original spot, 4.5 meters further to the left. Everybody see that? Okay. So now we go to the second part. It says find the total distance the particle traveled over the interval of 1 to 4. So let's do that. Distance well, it's pretty straightforward. What I need to do in that situation is the integral of 1 to 4 of the absolute value of the function. The absolute value of t cubed minus t squared minus 6 dt. What did I do? Oh, t squared minus t. Thank you. Sorry about that. Good, my velocity function. Now, does it seem odd to you to take the absolute value of a quadratic? We really haven't talked about that before, have we? We really haven't talked about that before. And so there's not like some crazy algebraic thing that you do in this situation. We don't want to do that. All we do is we just, this is all we do. We find the red area, which is going to be negative, agreed? And when we find it, we just make it positive. And then we find the blue area, and we make that positive. See what I'm saying? That's what we do. All right, and then we'll show you on our calculator. And after this, we're done for the day. And you can start working on that bit, and we'll slowly progress from there. So let's figure it out. If we want to do that absolute value, what we do is we do the integral from 1 to 4. Oh, I'm sorry. The red area, look at the red area. Where is the red area bounded? From what to what? Everybody see that 3 was an important spot to find, that's where I cross the x-axis? So therefore, I'm going to find this area, the negative area, which is going to be the integral from 1 to 3 of t squared minus t minus 6 dt. And then I'm going to find the positive area. And the positive area is going to be the integral from 3 to 4 of t squared minus t minus 6 dt. And we'll figure out what those are. We know the one will be negative, the one will be positive. We'll just turn them both positive and add them together. And then we'll verify via our calculator. We ready? Okay. Antiderivative, we've already determined it. It is t cubed over 3 minus t squared over 2 minus 6t, evaluated at 3 and 1. Three cubed, divide by 3, 3 squared over 2 would be 9 halves, and 6 times 3 is 18. And from that, I will subtract 1/3 minus 1/2 minus 6. So I'll come up with an expression there. 9 minus 18, -9, so I'm done with those. I'm going to do -9 halves minus a -1/2. Yeah, so that'll be -8 halves, right? Which is just -4. So I'm done with that and that. Plus 6 or minus 6? Plus 6. Plus 1/3 or minus 1/3? Minus 1/3. Okay, so I took care of all my pieces. And I've got -9 minus 4 is -13. And -13 plus 6, -7. And -7 minus 1/3. -7 and 1/3, right? Or -22/3, I'll write it as. Shouldn't it be positive? What are we finding again, folks? Finding the red area, right? So I expected negative, right? But we'll flip it, make it positive then. Because we traveled 22 over 3 units in the left direction. So we'll count that as positive in a little bit. First, let's do the other side. I have t cubed over 3 minus t squared over 2 minus 6t. Determine that from 4 to 3. All right. Plug in 4, what do we get? 64/3 minus 8 minus 24. And from that, I will subtract 9. 9 halves minus 18. Okay, let's figure out what we get there. 64 over 3. Negative 8, negative 24. So minus 32, so I'm done with those. 9 minus 18. Negative 9, and I'll make that negative, so plus 9. It's going to be plus 9 halves or minus 9 halves? Plus 9 halves. Okay, getting closer here. Doing our best to work without a calculator. Sharpen our mental acuity a little bit. Negative 32 and 9. Negative 23. Plus 9 halves. I'm feeling common denominators. What do you think? Okay, common denominators would be 6, so I multiply top and bottom by 2. So 128 over 6. 23 times 6. 138 plus, then what? 27 over 6. All right, 128 minus 138, negative 10. And negative 10 plus 27, 17 over 6. So I went negative 22 thirds in one direction and then 17 sixths in another direction. So we'll count that as positive. We'll do 44 over 6 plus 17 over 6.
You just make it positive?
Yep, we're counting that as positive because we're saying it's distance, regardless whether it's positive or negative. We don't care about the direction at this point. We want to know our total distance. So I see in that situation I get 61 over 6, which is, 10.16 repeating, right? If we write it as a decimal. Let's verify. Please take out your calculator so you can make sure that you do this correctly. This will be the first time you do this type of operation on your calculator. I turn it on, and I go into y equals, and we're going to enter in our velocity function, which is x squared minus x minus 6. I'm going to zoom standard, zoom 6, so I'm in a normal viewing window. Does that look like the picture of the graph that we drew originally? It does. Okay. But this time, instead of that one, we want the absolute value, don't we? So what I want to check is I want to check this work right here. And so what I'm going to do is I'm going to go back to y equals, and I'm going to put absolute value signs around that. Now, sometimes people wonder where you get absolute value signs. There's a couple places, but I like to use my catalog. So I'm going to insert. So second delete gives you your insert operation. And then second catalog, I could grab absolute value. So I've got absolute value of that, and I'll just close the parenthesis. Oh, so you got to type it back in then?
Yeah.
Sorry. So it's kind of cool when you graph this then. Watch what happens. As I press graph, what does it do to the parabola? It makes it above the x-axis the whole time, right? Because it's always positive. So it just takes that bottom part, flips it up. And so now we want to calculate the integral number 7, and we want to go from 1 to 4. And as you do it, you're going to see yourself accumulate from 1 to 4. And sure enough, 10.167. Your calculator is a little bit off. It's not as smart as we are. We know it's exactly 61 over 10. Your calculator, it's off by at least 1,000. Stupid calculator, huh? There you go. So take out your assignment. Show you what you can start focusing on. Okay, so right now, Alex is seeing this page right here that has 2 problems. The intention is that, you try to do as much of it by hand as you can. if you want to end, here's what I don't want you to do, folks. You see how what we did was just second calculate and we got the whole answer just like that? That's not what you're supposed to do. But if you would like to use your calculator for some of these numerical computations at the end, go ahead. Get my point? But show your work by hand. So just those two problems. After that, our problems are going to start requiring the use of a graphing calculator, and they're going to become a little bit more involved. And so tomorrow is a pretty big day. I would say tomorrow is, I'm not going to say the most important day of the unit, but tomorrow's, it's pretty critical.
Are we supposed to label 10.16 or?
Where we give it, well, 10.16 meters, sure. Yep, thank you. Thank you, Morgan. All right, there you go. You don't have a lot of time, but you do have a little bit of time to at least start it. I should have answer keys and stuff pretty much posted for the most part right now.